Good morning, dear students. How are you all? I hope you are all doing good and studying really very hard. Today we will solve another problem from book Virodo from chapter Kinematics, and the question number is 1.16. Let's read this question. Just imagine the situation and let's solve this problem using whatever concept we have learned. Okay, two particles 1 and 2 move with constant velocities v1 and v2 along two mutually perpendicular straight line toward the intersection point O. Okay, let's draw this first. So they are saying that there is two particle and they are moving along the two perpendicular straight line, right? Like this. Suppose this is x and this is y. Suppose particle 1 is here, or let me draw it here. Particle 1 moving with velocities v1, obviously they are moving toward the point of intersection, so this must be moving here. This is v1, and suppose particle 2 is here and it is moving toward origin with velocity v2. This is the case. Now at the moment t is equal to 0, the particles were located at distance L1 and L2 from O. So they are saying that this distance, or let me draw it again, this distance is L1 and this distance is L2, or I could have simply wrote the mentioned the coordinates. This is L2 and this is L1 comma 0. Okay, fine. So now what they are saying, this is the situation at t is equal to 0. Now how soon the distance between the particle becomes smallest and what is it equal to? So we want smallest distance possible between these two particles. Obviously their path is coinciding at O, but it doesn't mean that they will meet at O. Actually they may never meet, and we know that if they are supposed to meet, then they will meet at this point only, point O. The problem is they both will not reach O at the same point, right? So how can we solve this question? At least what we can do, we can write the distance between these two particles as a function of time. And yes, if you could find the distance between the particle at any time, then after that we can differentiate it, use differential methods to find maximum and minimum. We know that. So if at t is equal to 0, this particle was here, then after suppose t second, this particle will travel some distance. As we know, suppose distance traveled by this particle is v2 into t, v2 into t. At t, after time t, this particle 2 will travel toward O a distance of v into t. So what is the distance left actually? So I will say now it is at L2 minus v2 into t distance from the uh, origin. And suppose this particle also in time t will travel v1 into t. So I am assuming, suppose at time t the particle 1 has reached at this point, and this distance will be L1 minus v1 into t. Am I right? v1 into t. So at any time, if I try to find the distance between the particle, this particle at here and this is here, so distance between the particle will be this, the length of this line, and I can write distance will be equal to d is equal to under root of L1 minus v1 into t whole square plus L2 minus v2 into t whole square, right? This is the d, or we can say d square is equal to L1 minus V1 into T square plus L2 minus V2 into T whole square. Now we know that if for D minimum, what we can do, we know that D will be minimum at only at those time when dt by d capital D by dt will become 0. So let's differentiate this equation with respect to time. If we differentiate this equation with respect to time, then we will get 2 capital D into d capital D by dt dd by dt. And if we differentiate this, so all these we have to apply chain rule. So let's solve this. I will first differentiate the bracket, so I will get 2L1 minus V1 into T, and if we go inside we will get minus V1, right? And again, if I differentiate this, then I will get 2L2 minus V2 into T and minus V2, and we have to do this as 0. So if I put d capital D by dt as 0, so I will get this 2 and minus will be cancelled. L1 V1 minus V1 square into T plus L2 V2 minus V2 square into T. And from here we will get time as L1 V1 plus L2 V2 divide by V1 square plus V2 square. So this is the time at which distance will be minimum. This is the time at which distance will be minimum. So for time calculation, I think, sorry, this method is more easy, because differentiation is not really big deal. Anyone, you are, I think, I assume that you people are comfortable with chain rule and all this thing. If you are in 11th class, then you may face some difficulty, but yes, it's not difficult. And if you are in 12th class, then obviously then you are a master of integration and differentiation. Now if we have got time at which distance will be minimum, if we can put this t here and we can solve. So I am giving this task to you, you solved it and match your answer finally. Now to calculate distance, minimum distance, we have another method by which we can do it very easily and quickly, and that method is relative method. So we are going to solve this problem using relative motion concept. Okay, let's solve that question in frame of particle 1. Okay, so with respect to 1, we must know that with respect to 1, for an observer always stays at rest. So with respect to 1, velocity of 1 with respect to 1 will be 0. This is clear. And we know that, we must know that this as a mantra, that when an observer try to observe the motion of any other particle, what he do? He reverse its own velocity and give that velocity to the object and take resultant of the velocities, and whatever resultant will he will get, that will be the truth or reality as seen by the particle 1. What I am telling you is that, like, if we want to find velocity of 2 with respect to 1, then what we do, velocity of 2 minus velocity of 1, or we can say velocity of 2 plus minus of velocity of 1. So in order to obtain what is the velocity of particle 2 as seen by 1, what we are doing, we are taking resultant of these two, this velocity of the object and negative of the velocity of observer. This resultant of these two vectors will give the reality as seen by particle 1. So with respect to particle 1 has now come to rest. Now he will not move, only particle 2 will move, and yes, this is the reality. So we what we have understood from here, that particle 1 will reverse its velocity and give it to particle 2. So let's give it. So this will become minus v1, minus v1 vector, and this is going to be the resultant, right? On obviously you can see v2 plus minus v1, this is velocity of 2 with respect to 1. So according to particle 1, the reality is that particle 2 is moving along this direction. Simply particle 2 is moving along this direction and nothing else. And he is simply sitting here, and particle 2 will be continuously moving like this, and when it will be at the minimum distance at this point. So minimum distance will be the perpendicular distance. So we have to find this d minimum, right? Okay. So now this we know that from origin to 1 distance is L1, and we know that this distance was L2, right? So for d minimum, let's say if I say that this angle, or let's say this angle is theta, and if we can find this distance, this is not difficult, this is suppose x, if we could find this distance, then I will say d minimum is equal to x cos theta. And how can we find x? We need to find this distance. Can we find this distance? I think yes, we can find this distance. Let's say this is L maybe. So uh, if this is theta, then this is 90 minus theta, and this is also 90 minus theta, and if this is 90 minus theta, then this will be theta, obviously, that is right angle triangle. So we can see tan theta. If we see this triangle, tan theta will be equal to L upon L2, L upon L2. And if we see this vector diagram, then we can see tan theta is equal to v1, this length is equal to v1 by v2. So this is also equal to v1 by v2. So here we got v1 by v2 into L2, this is L, and now x will be L1, x will be L1 minus L, right? So d minimum is equal to L1 minus L into cos of theta, and L1, what is L1? L1 minus L, L is we can use this v1 L2 by v2 into cos theta. Now how can we find cos theta? I think we know tan theta is equal to v1 by v2, so cos theta will be based upon hypotenuse. What is base? Base is v2, right? I think you all understand how to solve this type of, this is suppose right angle triangle, and this is theta. So this is tan theta, this is v1, this is v2, and this is under root of v1 square v2 square. And from here we can see that cos theta will be v2 upon under root of v1 square plus v2 square. So v2 upon under root of v1 square plus v2 square, and let's solve this fast. I will say this is L1 v2 minus v1 into L2, v2 will be cancel out, and under root of we will get under root of v1 square plus v2 square. This is d minimum. So this is I think a lot more easier to solve. And how we can find time? So this is also not difficult. Like if we put some name here, this is A. This is suppose point A. Suppose this is point B. Suppose this is point C. So only we have to find AC length AC, and this whole distance AC, the particle has travelled with velocity with speed v1 square plus v2 square under root of v1 square plus v2 square. This was the speed. So finally time will be AC divided by under root of v1 square plus v2 square. And how do we find AC? I think that is not difficult now. We know this distance. Okay, 1 minute. Let me see how can find. Okay, I got it. We have already known d minimum. If we join this line, what will be the length of this line? This line will be under root of L1 square plus L2 square. So AC will be this is hypotenuse. I think this is so this is hypotenuse. This is d. I will write this square minus d minimum. So finally L1 square plus L2 square minus d minimum square, and divide by under root of v1 square plus v2 square, and you will be able to solve this quickly. It is not really that difficult. You have to square just this term. This term will also be squared, and you will see around four terms will cancel each other, and yes, you will get the answer. I hope students you have learned the concept here, and okay. So if you learn anything from this video, do like it, and also if you are not subscribed to this channel, do subscribe, and don't forget to press the bell icon, because you will get the notification instantly whenever I upload the video, and you will not miss any video. Okay students, happy learning.